All right, the last thing that you might have to find in a right triangle is one of the angles. Now this can only happen if you're given two of the sides. Before you were given one side and one angle and you had to find the other stuff. So if you have theta that you're trying to find, you need to at least know, two of the sides. Real quick before we get into how, you need to know where the buttons are. When you were evaluating regular trig functions, or maybe you haven't done it yet, on your phone, right? This is on an iPhone. I don't know what the calculators look like on the other phones, but I imagine they're set up with the same thing. The pictures are kind of blurry, but if you do the calculator on your iPhone and you take off the auto rotate, if you rotate it, it pulls up a bigger calculator, a scientific one. Main thing you want for right now anyways is to make sure this is in degree mode, and this should say rad. If not, push this button. And then if you look right here, there are your three trig functions, sine, cosine, and tangent. Now it's a little bit backwards because you don't go sine and then the angle. You would have to hit, 6, 0, and then cosine for it to find the sine of that angle. So it's a little bit reversed. So angle and then the function. So make sure you're in degree mode. That was this guy, right? Same with down here, evaluating inverse trig functions. To do inverse trig functions, you have to push this button or this key right here. It's the second. And then you'll see, again, my picture's fuzzy, but you'll see when you push second that these three change, and they've got this little -1 looking thing up in the power. Whoops. So it'll say sine like normal, but then all of a sudden it'll say with a -1 up there. And then also cosine with a -1. That -1 right there stands for inverse, and that's actually what you're going to use to find the angles in a right triangle when you're given only two sides. So on a calculator, iPhone calculator, but again, I imagine some the other phones have similar functions to them. Okay, on a regular TI 84 plus or TI calculator, they're all pretty much the same. To make sure you're in degree mode, the other mode is called radian mode, and we'll get to that, but for right now, all we're dealing with is degrees. Here's the button. So if you push that button right there where it says mode, it pulls up this screen, and this is what you want it to look like. You want the degree word to be surrounded by a black box with degree in white. That lets you know that it's, in that mode. If it was a black box around radians, then it's in the other mode. And then for regular trig functions, hopefully you found these already. They're right there. But for inverse trig functions, they're right here. And you have to push second button first. Then these guys. These guys are just regular sine, cosine, and tangent. You don't have to push anything but 4. But this is for inverse. You have to push the second button first, and then those ones above it. Calculators are like normal. You push the buttons, push the trig function first, and then enter the angle in later. Calculators the only ones that are backwards like that. Okay, third option is when you use Desmos. Again, you have to make sure you're in degree mode. When you're using these functions, though, you have to hit the keyboard button on the lower left. It pops up this menu, and then when you click on the functions, the first menu it pulls up is your trig menu. Now, again, there's the original functions, sine, cosine, and tangent. Desmos is nice because it has these guys too, but you don't need those because you can just always flip reciprocals. I mean, I guess they'd be nice if your answer was in decimals, but they're not necessarily necessary. So these are the regular ones. And then if you want to do the inverse ones, that's these. And they work just like the calculator. You push the button, it'll pop up in here, sine -1, open parentheses, and then you'll type in your, degrees or whatever, 60, close the parentheses, and when you hit enter, it's going to pop up and tell you the inverse is numbers in between 0 and 1. We'll say 5/12 or something. Sorry, got thinking back at this other one. I said angle, but oh, that's for these guys. For these guys, you would enter in the other one. I'm going to show you some examples. That's better. Okay, so Desmos will do both. To make sure that it's in degree mode, you need to click here, right? The wrench, this is the tools. And down here is your rating in degree. This one needs to be green. Then if you were to type in like sine of 30, it gives you out the answer for that. If it's not, if it's in radian mode, you get a completely different answer. When it's for inverse sines and that, what you're going to end up doing is putting in a value like 1.7, and it's going to kick out, I don't even know one off the top. Let's do 0.7, and then it would probably kick out something like 45 as your answer. That's degrees because we're in degree mode. And again, I'll show you a couple of these. Okay, so finding angles in a triangle. The ones before, finding sides, it was the same idea. You had to use, figure out what angle to use, label the sides, decide which trig function, set up an equation, and then solve. The only difference is this time, instead of solving, you've just got to use your trig functions. For example, here's the angle that I'm trying to find, x right here. Okay, located that angle. I'm going to label my sides. This is the hypotenuse. This is the opposite, and this would be the adjacent. If you look at that though, I only have opposite and adjacent. So I'd ask myself, which trig function uses opposite and hypotenuse? Those are the only two values I have, so that's the trig function that I'm going to use, and that's sine. So Kotoa says it's sine of an angle equals opposite over hypotenuse. All right, so to find x, it would look like this. The sine of x equals opposite, which is 15, over the hypotenuse, which is 17. Now to solve for an angle, that angle is x. So what you do is you reverse it or do the inverse. And instead of doing sine of an angle, you're going to use that sine with a -1 up there of that fraction. So this inverse sine, this sine with a little -1 up there, is the reverse of this guy right here. And then when you pop that into a calculator or into Desmos or whatever it is that you're using, you pop into Desmos. All right, Desmos graphing. Trying to make sure you can see the whole screen at once. All right, first of all, this right here, I'm going to make sure I'm in degrees. And then to do sine, I'm going to open up the keyboard, functions. I'm trying to find an angle, so I need the inverse sine. That's all that little one means right there is inverse. So then I type in my ratio, and it says it's about 61.9 blah, blah, blah. I think it said to round to the 10th place. So 61.9 degrees because that's the degrees that we're in. No. I got that backwards, didn't I? 61.9. And that's what x is. So finding the angle is actually a little bit easier because it's less work. All you do is change it to inverse sine of those numbers. So find the angle that you're being solved for, label the sides. You still need to put in your O, A, and H. And then it's a matter of which trig function uses those two sides. Set up your equation. X is the variable. It's going to be over there with the trig function, not a number. And then use the inverse. Let's try another one. All right, here's my angle right here, theta. What I have is opposite and adjacent. This would be hypotenuse, but I'm given opposite and adjacent. So since the tangent of theta, according to SOHCAHTOA, deals with the opposite divided by the adjacent, we're going to say tangent of theta, was called theta, this guy right here, equals 8 over 5. So to solve for theta, you change it to inverse tangent and then type in that fraction. So right here, whoops, I meant to go backwards. Okay, so hit functions, this time we're using inverse tangent, and it was 8 divided by 5. Enter. Looks like 57.99, which actually will round to 58. Can't round to tenths place. So theta equals 58.0 degrees. Okay, next one. Here's my angle theta, and I don't have the opposite. I do have an adjacent and a hypotenuse. Well, the trig function that deals with opposite and hypotenuse, sorry, adjacent and hypotenuse is cosine. So cosine of theta equals adjacent over hypotenuse. That means theta, my angle here I'm trying to find, equals 7.5 over 9, which means my angle theta is cosine inverse of 7.5 over 9. And again, use your calculator, use Desmos. I'm going to use my calculator sitting right here. Looks like it's 33.6 degrees. So much easier with the inverse ones. Finding the angles is much easier. Okay, this last problem deals with finding everything in the triangle. I found this third side right here, trying to save some time before we started. So what I want to do is find this angle theta, right? So in the problem, I was given the opposite and the hypotenuse. I have the adjacent, but I don't want to use something that I had to compute myself. So I'm going to use the sine of theta is 4 over 10, which means theta equals that inverse of 4 over 10. You can reduce along the way, it doesn't really matter. Which tells me that theta is 23.6. Now to find that other angle, right, this angle right here, I can just take 180 minus 90 minus 23.6, which is 66.4. So I have found my other missing side and my two missing angles, and that's it.